In this video, we are going to walk you through how to use KnowItAll's Trendfinder, a powerful tool that applies principal component analysis, or PCA, to help you uncover meaningful patterns in complex datasets. Whether you're working with spectra, chromatograms, our reference datasets, or your own databases, Trendfinder makes it easy to visualize relationships and detect trends that might otherwise not be obvious at first glance. Unlike traditional chemometric tools that can feel intimidating, Trendfinder is designed to be intuitive and approachable, even if you don't have a background in statistics. You can bring your own data or explore KnowItAll's collections to investigate correlations, identify outliers, and reveal hidden structures within your dataset. We'll show you how to load your data, interpret PCA plots, and use Trendfinder's interactive tools to explore your results from different angles. These capabilities make Trendfinder especially valuable when you're dealing with large data sets, subtle variations, or complex unknowns where patterns aren't immediately clear. So let's get started. Navigate to Trendfinder, which you can find under Spectral Analysis in the left navigation bar. We are going to load a new PCA. Click File, New PCA. And in this case, I'm going to select one of our Wiley reference libraries. The library I'm choosing to analyze is our automobile paint chips library. I found the library and click Add. I don't want to bring in the whole data set, so I'm going to limit to a certain range. Under Record ID Ranges, select your range. I am selecting records 1 through 200. Click Next. Once the files have been successfully analyzed, click Next. For the next step, we are going to choose a field to analyze. In this case, these are IR spectra, and I'd like to analyze the IR spectrum. Field for classification. In this case, I'm interested in looking at the different paint types and how they plot on the PCA. So I'd like to select the field for classification as paint type. If you leave this blank, that's no problem. You'll see the natural distribution, and you can play around with the different classifications after. In the next step, we are going to choose our analysis parameters. The first thing you'll notice is our pre-processing parameters. Now I'll leave it at mean center, but there are quite a few to choose from. Next, we are going to choose our Y transform. Because this is IR, I'm going to use second derivative. If you're using NMR or mass spec, you may wish to use divide by instead. The next parameter I will direct you to is the number of points. In this case, it's pre-selected 5, which says we are looking at 5 points on each side of bell-shaped peaks. I'm going to increase that to 11. Now, if you have very high resolution data, you may wish to use the ranges and binning bucket at the top. If I select ranges and binning, and I click Next, it will pull up step 6, ranges and binning bucketing. The binning and bucketing is going to reduce the resolution to help process the data. If you'd like to include only a certain range of the data, simply click Include and drag and drop your cursor to select your included range area. Likewise, if you'd like to exclude any parts of the spectra, simply drag and drop. Next, you would be prompted to auto-generate bins. So you can click Auto-generate bins, and you can use intelligent bucketing, which is going to make sure that the peaks are not cut in two. In this case, we are not going to bin our data, so I'm simply going to navigate back and remove the check from ranges and binning bucketing. Now I'll click Next. I get the report that the data has been processed successfully, so I'll click Finish. Now you can see that my data has already been clustered and colored according to the categorization that I selected, which was paint type. So in this case, if you'd like to have a look at the data, you can select Orbit, X and Y, which gives you the option to have a look around to see how your data sits on the PCA. If you'd like to reset it, simply press Reset Display. You also have the option to view your data in 2D. Click 2D, and you can see your data in 2D. I'll leave it at 3D for now. Now, once you've loaded your data into the PCA, you have a number of different options. You can use your selection mode to click through all of the different points, which will show you their record in the top right corner. It will also show you a heat map to show overlapping peaks in the records that you've selected. I can select a number of spectra simply by dragging and dropping. The next thing you might want to do is look at the overall variance. So this overall variance in a traditional PCA is telling us how many factors contribute to the overall variance of the data set. You may also want to look at your outlier diagnostics to see if there are any outliers in your data set. And we're looking at any records that exist on the right of the plot. It's possible that you may want to plot an unknown into the PCA space to see where it falls in terms of your clusters. To do that, simply click Database Projection. Here we are going to pull from the same database, but this time I'm going to look at record 1001. Now you can see, we see our clusters from the original PCA all in blue. The unknown we've just loaded in is this black dot that exists within the green cluster. So if I go back to scores and I navigate over to our legend, which tells us paint type, I can see that green cluster is the acrylic solution lacquer. If I go back to my database projection, I can see that this record, falls within the green cluster, which is a lacquer. If I click it and look at the information, you can see that it's fallen within the right cluster, as we can see paint type says acrylic solution lacquer. So in this case, there may be an example where you do not know what the unknown is, and you're able to plot it on the PCA to see where it falls to help classify what type of compound it might be. I'm going to pull up another data set to show how you might use the loadings plot. So if I pull up this data set here, let's take a look at it. So if I go to my loadings plot, it's going to look a lot like a spectrum, but it is not a spectrum. It is showing the relationship between the original variables and the principal components. It helps to understand how much original variable contributes to principal components and the nature, whether it's positive or negative, between these contributions. Now in this case, we can transfer to search it, use our peak picking tool, and I'll remove the spectrum because this is not a spectrum. Adjust your minimum peak intensity and click Pick. You may want to adjust the peak search options, and you can click Peak Search Options below. Minimum number of peaks to match, you can increase. So now we're looking at a minimum number of 6 peaks to match in order to get us a match in our libraries, and click OK. So now we can go ahead and use this loading plot to see if we can match any of the strong peaks within it to spectra in our libraries. And that would be a perfect example of when you might be looking for a biomarker that's influencing the overall variance of your data set. I'm going to jump back into Trendfinder to show one other way you might load data into a PCA. It's possible that you might be in MineIt editing a data set that you've made. In that case, you can simply move from MineIt over to Trendfinder with the database you already have open. So in this case, let me highlight all the records that I've opened in this database. If I scroll down, there's 200 records I'll be pulling in to Trendfinder. Now we can simply use the transfer to Trendfinder. We're going to start a new PCA. And now in this case, we are going to use the mass spec GC spectrum. I'm not going to select a field for classification. I want to see the natural distribution. Click Next. Because it's mass spec, I'm going to choose Divide By. And in this case, I'm going to use Sample Max. So now you can see all of the data displayed on the PCA. In this case, we're looking at the natural distribution. That's when you may want to use the categorization button under display options on the left-hand side. Here you have 4 options: color, symbol, size, and label. And you can play around and have a look at how the different fields cluster either by color, symbol, size, or label. So let's pull up an example. Here I've selected molecular weight, so you can see the distribution via the color. If I wanted to look at the data a different way, I might reset categorization, and now I'll look at molecular weight via symbol. Here you can see we have some clustering at the bottom. So this is simply a way to visualize the data to see if you have clustering or if there are any trends or patterns you might see. Another note that you might want to look at is the substruct calculation. You can see that each record has a structure. When I jump back into Trendfinder, you have the option to calculate all substructures within the dataset. So when I click it and I'm going to sort by abundance, you can see that all 200 records in the dataset I pulled into this PCA have benzene. Likewise, as you go down through the abundance of the substructures, you'll see how many times each substructure appears within the dataset. That's a quick tour of how to use Trendfinder to reveal patterns, relationships, and hidden structures within your data. As you continue working with your own data or KnowItAll's collections, try experimenting with different views, zooming into clusters, exploring how individual variables contribute to the variation you see. Trendfinder is all about helping you see your data from new perspective, and I hope this demo gives you confidence to dive in and start exploring. Thanks for watching.